Hi, today we are going to discuss another problem which is jump game problem. In this problem we are given an array where each index holds a value which is the jump from the current index, max jump from the current index. For example, this is the index 0 and it has a value 2. So from this index we can jump max to this index. We can jump from this index to here and max to here. For example, and also from this first index we can jump max to this fourth index. So to solve this problem we'll be following the greedy approach. There's another approach for this using dynamic programming, but it's non-intuitive, so we'll be using greedy approach. So in greedy approach, for each index we'll have I plus the value of that index, that is this is equal to the current max, that is the max jump from the current index, and also we'll be storing another value, that is max so far. That means suppose we have traversed till jth index, and whatever the maximum index we could cover while traversing all the indices from I to j or 0 to j will be our max so far. Now when we have max so far, we'll always be comparing in each iteration to uh, the last index, that is length minus 1. If we are able to reach this from any index, we'll return true. Else, after traversing the entire array, if we are not able to reach in last index, we'll return false. For example, in this array, the max we can go from 0 to 0 will be this, and again from 1 will be this, and again from 2 will be this. So we'll never reach 4 from I from 0 to 3. So for this our function should return false, and the time complexity for this approach will be O(n) and space complexity will be O(1). So how are we going to solve this problem? Let's write down the program in Java. Public boolean can jump int jump. We'll have one variable max so far, that is equal to 0. Initially it will be 0. If jump dot length equals to 1 will return true. For example, suppose jump equals to, even it's 0 or if it's 1, it will always be at the last index, so it should always return true. Now let's start traversing the array. For int I equals to 0, I less than equals to max so far. This is a very important condition. I'll tell you why I have used max so far and not less length. Now our max so far will be math dot max of max so far and I plus jump I. So what is this step? This step says like whatever max I have reached till some index, say I, and I am currently at index j. So whatever max I have reached from here, I need to check if I surpass using this index or this one is still the max value. That means the max that can be covered till 0 to j. This step says that. Now if my max so far is greater than or equal to jump dot length minus 1, I'll return true, else return false. Now I'll explain this condition, this one. For example, if you have 3, 2, 1, 0, 1, 4, and you start traversing this, from this max you can go here, from this max you can go here, and again from here to here. But suppose if you use I less than length, then after you have exceeded this index, you'll come here. Now from here it will be reachable, but if you'll see, you can't go after this, because 0 is like you'll always be constant here. That's why max so far will be this index, and if I exceed this index, if I exceed max so far, like if I is greater than max so far, that means I am here and my max is here, that means it's 0, so it should break after this. That's why this condition. And again, the time complexity is O(n). We have solved this in one pass, and space complexity is again O(n). This is a solution, efficient solution for this problem. I hope it's clear. Thank you so much.